Welcome, everyone. Thank you for waiting through our technical stuff there. The lesson is turn in your slides on time, so they actually have them on the laptop here. So you don't have to run around and try to get them on at the last second and find a thumb drive that'll actually work. All right. My name is Alan Gates. I'm one of the founders at Hortonworks. I've also been involved in Hadoop for 11 years now, which I'm getting tired of saying because it just sounds like a long time, but makes me feel old. Anyway, I'm a member of the Hive PMC, a number of other things. And I want to talk today about metadata across both data at rest, now the marketing term is data lake, and data in your streams. But first, a warning, this is going to seem like a little bit of a circuitous journey. I'm going to take several side steps. I ask you to believe me that I really am getting to the end point. I'm not just wandering aimlessly about or just talking about my favorite things. So another way to think about it is my undergraduate degrees in mathematics, and any of you who've taken math know you got to prove this and then prove this before you can prove your final theorem. And then maybe some corollaries fall out of that too. So I think that still influences my thinking. At least I've been told that when I write, that I still write like I'm in math class sometimes. So if it feels like I'm wandering around, just please bear with me and remember I probably know, well, I know where I'm going. We'll see if it makes any sense. All right, so I want to talk about first metadata in the SQL side of things, because this is kind of where it starts. So in this somewhat random sampling of 4 big SQL engines, I just took here Hive, Impala, Presto, Spark. All these can do SQL on Hadoop, and they have an interesting thing in common. They all use the Hive Metastore. And Hive didn't actually set out to make this happen. It didn't, go to these other projects and say, please use our Metastore. The other projects just look at it and said, okay, this is already here. No reason to reinvent this wheel. It kind of works, right? So what's good about that? What's good is this makes it a lot easier to share data between users, right? If one team is using Hive and the other is using Spark, they can share their data, their tables. Now you have to do some things to make sure that works, because Hive and Spark can't read 100% of each other's data, and there's a little bit of stuff to do, and I'll talk more about that later. But in general, you can still share all this. And that's really fundamentally important. This is as important as having a shared storage system like HDFS, or if you're in the cloud, an object store like S3 or WASB or whatever. Because it means you can share the data between them. So what's not good about this? There's a couple things that I see as problematic here. One is if you aren't Hive, you're forced to install quite a bit of Hive in order to get just this one component. Hive traditionally has not done a great job of making itself into different usable components. It kind of comes as one giant blob, and you need to install large parts of it. Now, if you're building a distribution or something, you can just take the parts you want and put it in there, that's fine. But if you're just an end user trying to build a system, you end up with a lot of extra stuff you don't necessarily want. The other, and I think more important thing, is if you're part of one of these other projects and you want to contribute to the Metastore, that's not super easy. Let's assume that Impala wanted to add a geotype as in standard type in its system. If they come to the Hive team and say, hey, we'd like to make this change in the Metastore, why is the Hive team motivated for that? It's not part of Hive, right? So having this shared component embedded in one place makes it hard to share, which is not the way Apache is supposed to work. So the first proposal, we need to pull the Metastore out of Hive. It needs to not just be part of Hive alone, but it needs to be something that everybody can share. We've actually started on this. some work started in the Hive community a year ago. Was it last summer we started? Something like that. To actually pull this out. Where we're at right now is as of Hive 3.0, the Metastore is a separate module. It can be deployed without the rest of Hive. It's actually a separate release. You can download either the source code or a binary from Apache and use that. And it mostly works. There's a couple in-depth features there that if you use, like the ACID compactor and a couple other things that are still in Hive that the Metastore doesn't have access to without the rest of Hive. But for general purpose, serving metadata, recording table information, all that is all there and can be done. We worked very, very hard to keep this backward compatible for Thrift clients. So even though we're pulling this code out and having to make changes here and there to extract it from Hive, we kept the backward compatibility in the Thrift client. So older clients can still talk to this newer Metastore. Now, if you have, the Metastore offers a number of hooks inside where you can write hooks into it to do things like, for example, make security checks or those sorts of things. There are a few small changes there because, again, we were pulling this out of Hive. We had to change some of the classes here and there, but they're very minor and shouldn't take you more than a day to make those changes and get it going again. Now, today it's still inside Hive. It's still part of, as far as community-wise, I mean, not code-wise. There is a proposal to pull this out and make it a separate top-level project. And in good Apache style, we talked for a little bit about making it a separate project and then argued for a month about what the name should be and then haven't talked about it since. But this is something we want to keep driving forward. And there's a little bit of, some people think it'd be better to just make it a sub-project inside Hive. Some people think it would be better to make it a standalone project. I'm definitely in the standalone, in the top-level project camp, but we'll see where that lands. Now, let me bring out kind of another reason why this is important that I didn't cover so much here, because here I'm kind of thinking from a community perspective. But now let me look at this same question a little bit from a deployment perspective. And you can always tell in my slides when I steal from marketing, because all of a sudden they get colorful and artsy, and then they go back to just text, and so you can tell which are mine and which I stole from our marketing department. But as was mentioned yesterday in the keynotes, shared services in a cloud environment are very important, and they're important to be there all the time. And what's in these shared services? Metadata, security, and governance. So another reason it's important to have the Metastore where it can be pulled out and where it works with all these different projects is because in the cloud, you want this to be always present. You don't want to run a cluster all the time in the cloud. That's way too expensive, right? So you see the ephemeral workloads and on-demand part of thing. And you're going to have your data stored in S3 or WASB or what have you, but you want that metadata there all the time. This is another reason, oops, hope that wasn't important. That's another reason that having this separately installable and shareable is very, very important. All right. So this brings up a question. It's a very fair question. Did we do this before? Is this just HCatalog rehashed? Weren't you talking about this 5 years ago? No, it's not. It's actually different. And let me explain that difference, because this is important, because a lot of people miss this the first time around. HCat really focused on making the Metastore accessible for the tools that were around when it first started, which was mostly Pig and MapReduce and later Spark. But this included not just accessing the metadata, but also it included SERDES, object inspectors, and input-output formats so that these guys could read Hive's data and write to Hive as well. That's important. It's a legitimate thing. It still needs to be there, but that's not exactly what the Metastore does, right? That's Metastore plus access layer, if you will. So in this split, amusingly enough, HCatalog stays with Hive. It did not come out as part of the Metastore. It is not part of that separate release. It is still a part of Hive. All right, now, as I warned you, there's zigs and zags in this presentation. So here's one of the, we're going to make a left turn here for a little bit and talk about data in streams. You know, 5-10 years ago, most of the data we were focusing on was data in Hadoop or in your object store. That's still very important data, but a lot of data now is frankly on the move or out on the edge. And we need to be able to keep track of that as well. So we've seen the growth of what I'll call schema registries. And there's a couple out there. Confluent has one for that they ship with their products. Hortonworks has one. I'm going to use the Hortonworks one because I'm familiar with it and because it's the one we're actually trying to integrate here. So what does a schema registry do? It provides a central repository for metadata about messages that are in your stream or on your edge. So this might be data in Kafka, might be data in NiFi, could be in other tools like that. These look a little bit different than the traditional SQL metadata, right? The schemas are defined in JSON. It's tied to a Kafka topic or NiFi flow. A schema has a name, but now here's where it starts to get a little different. Schemas can have versions, because think about the case where you have thousands of sensors out somewhere. Maybe they're taking weather statistics, weather data all out around your region, and every minute they wake up and measure the temperature and whether there's currently rainfall and whether the sun is out. If you have thousands of sensors out there and you push an update, that's not going to happen all at once. It's not like you can say, well, the schema of this data as of this moment is different. That update's going to take time to propagate. In fact, it may take days or months to propagate because you may only do it as you go out and change out the sensors or something. And so at any given time, you're going to have messages in your stream with different schemas. The first message might be version 1, next one version 2, third one version 1, and so on. You have to be able to handle that. These schemas also have life cycle states. Did we just start? Are we testing it? Is it enabled? Is it old and archived, like it's not valid anymore? If we see this data, we should put up a flag and say we're getting old, invalid data. So there's some nuances and differences there. Let me give you an example of what this looks like. This would be a schema for a very simple temperature sensor somewhere. Has the, let's see if I have has the ID for the sensor, has a location with longitude and latitude where the sensor is placed. And the reason I chose that example here is oftentimes these schemas will have nested structure, right? They don't tend to be flat. SQL schemas can also have nested structure, but in at least more traditional SQL, you don't see that as much. And then here you have temperature and the time it was read at. Notice also these types. This is not a date type, even a date time type, even though it was a time that you read it. It's just a long, all right? Very simple, more Java or programming language type types rather than database types. So this just kind of summarizes those differences that I was pointing out, right? In SQL, schema is tied to a table, or in Hive sometimes to a partition, but there's at least supposed to be some compatibility between them as you move through partitions. Versus here in a schema registry, it's going to be tied to a topic, a data flow, something like that. Schemas apply to all records in a partition in Hive versus what I talked about with different records might have different versions in the registry case. How that schema is laid out is going to look different. How you access that schema, that it's going to be via SQL versus Java or REST. And then the other big one here was the types, SQL types versus Java types, right? So there's bringing these together is not going to be trivial. There's some differences. But that said, we still want to figure out how to bring these together, right? Why is that? Why do we want to do that? So let me talk about a couple problems I think we have here. One is if we don't bring them together, right now, if we have still the Hive Metastore and one or more schema registries out there, we're just adding yet another component to the system. This is something else for administrators to install, monitor, and update, manage, all those things they have to do, right? Everything we add is one more thing to manage. It's also one more thing to develop and maintain for your developers. That's one more system that does pretty much the same thing as the other system. So there's some problems there. And then finally, these systems are not independent, right? They're integrated with systems like Ranger or Sentry that do security. They're integrated with systems like Atlas that do data governance and metadata management. All those things have to integrate with these systems. So as you multiply systems out there, you're multiplying edges in your graph for integration, deployment, testing, management, all those things. The second one is if you hardwire the perspective of the metadata into a repository, it makes it harder to share data between your applications. And let me kind of explain what I mean by perspective. Each of these, like in the, well, maybe it's just easier to go back here because I'm kind of switching words here a little bit. But by each of these sides, I mean a perspective, right? I talked about how some of these think about SQL types versus programming types, schema tied to a partition versus tied to a record. Those are perspectives. But sometimes your streaming application is going to need to read data from a table. Just sometimes it's going to need to, and I'll give you an example in a moment. Sometimes your query is going to want to read data from a stream. If you want to do that, every tool has to know how to talk to these different types of metastores. So, my second proposal, cross the streams. And we'll see if anybody here is old enough to get my movie references. But what I mean by this is put the schema registry on top of the metastore. So I am not saying force streaming people to think about their metadata as if it's SQL. They have a valid reason not to, right? But enable this one system to think about metadata either way, depending on what they want to, how the application that's using it wants to think about it. This means less work for admins, developers, and the tool integration. It also means it's easier for apps. Let me give an example, and I want to be very clear this is completely slideware, what you're about to see. Okay, we have not done this integration. I'm not promising this works today, but I just want to give you an idea of why I think this is important and where it could go. So let's say you have a streaming application, and this is user events. It's basically tracking things your users do on the website. And let's also say that you have a table inside your Hive database that records support calls you got from customers. Now, as you're watching, or as some application there in your stream is watching these user events come across, one thing that you'd like to be able to do is say any user that's called for support in the last 24 hours, if I see an event comes across that means they're still having problems, I'd like to flag that and send it maybe to an operator so that the user doesn't have to call me again and say, hey, it still doesn't work. What the heck is wrong with you people, right? You'd like to pop that up immediately. The data you want, the user events in Kafka, but your support calls are in Hive. If that metadata in Hive can be viewed by your streaming app as if it happened to be in a stream, if it can still think about support calls as if it were a schema registry schema, that makes it easier for your app to read it. Can you do this without it? Yeah, you could. You can teach your app to talk to Hive and cache the table every hour. And you're going to want to cache the table anyway because you don't want to be hitting Hive every time an event comes across. That's not real scalable. But with this, it's easier for your application to not switch into thinking, oh, I'm thinking about Hive now, I need to think about SQL, versus I'm talking to a stream. Now let's think about the same thing from the other direction. Maybe you have a query. When would a query want to read a stream? Let's take the same user events thing and assume that it's loaded out of Kafka into a Hive query every hour, maybe every 15 minutes, whatever you want. But maybe some of your queries, and probably for the vast majority of your queries, that every hour is just fine. right? It's going to give you what you want. You can build your reports, all that. But maybe occasionally you need to know up to the very last second. You really need to know what's happening. Well, that data is in your Kafka topic. So what if you could define a partition in your Hive table that is latest? That is, here's what's in that Kafka topic. And if these two are unified, if Hive can view that as just another partition and not have to understand that it's actually a stream, it can read that data. Now, there are other ways to do this today, just to be clear. You can use Hive streaming to ingest quickly from Kafka and be up to the last maybe 5 to 10 seconds. And I'm not saying anything bad about Hive streaming. I helped write the first version of it, so I think it's a great thing. But it doesn't solve every problem you have, right? I think there's still a place for things like that. Now, as I said, that's largely slideware at this point. The work has been begun to port the Hortonworks schema registry onto the Metastore, and the goal is to contribute it into Apache as we do that, because right now it's open source, but it's just in Hortonworks GitHub, and we'd like to contribute that into the Apache, into the Metastore. And so if you're interested in that work, you can keep track of it with these sets of JIRAs and pull requests that have been contributed that are basically blocking because the guy on the stage hasn't reviewed them and given enough feedback yet. So, but that's something we'll be driving forward over the next few months. All right, now, another zig in our journey here. So, can you share too much? I've been talking about how wonderful it is to share things. Is it possible to share too much? Anybody who's spent much time on Facebook will say, yes, you can. Yeah, you can share too many things. And let me give you an example of where that might happen. Let's say that you have a system, a setup where you're using Hive LLAP for analytics and you're doing ETL with Spark. Obviously, you want to do this with one Metastore, right? There's just all kinds of reasons. And you can do this today with one Metastore. But there are places that Hive and Spark don't always play well together. If you're using ACID tables, Spark doesn't understand how to read those because it doesn't know how to read the valid transaction list. So it will just think every record in there is valid, not realizing that there's actually 3 or 4 copies of some of the records. Different use cases might require different security models. Depending on how you're doing your ETL, you might be using storage-based auth, which means just whatever the files say. But for your analytics workload, storage-based auth is not going to work. You're going to want Ranger or SQL-based auth or something else. And different defaults might be appropriate in those different cases, right? LLAP, we have to run it as the Hive user because it's a big shared service, right? We can't have it running different processes as different people. In the Spark world here, for ETL or whatever your ETL tool is, even if it's Hive, the odds are fairly good that you actually want that to be, you want do as, what we in Hive call do as equal true, meaning do it as the user because you probably want that user to write that data. So how do you do this? So our third proposal here, or my third proposal, is adding catalogs. Catalog is a standard SQL top-level container. Kind of the standard hierarchy in SQL is catalog, database, or schema, depending on what you call it, but we don't use that term because we mean something else by schema, and then tables and functions and views and those sorts of things. So we have started the work on adding these catalogs to Hive. The groundwork was laid in 3.0 and a default Hive catalog added and all the existing databases placed in it, but it's not exposed out to SQL yet at this point, so it's still a work in progress. The goal here is that we can use these different catalogs to have different settings, different defaults, and different tools can use them and then make intelligent choices about how and when to share across them, right? But when you're moving across that catalog boundary, you know that you're moving across the boundary and you may need to use, that may affect security and other settings. So to go back to my example I had before with my advanced artwork, you can see here, LLAP can use the Hive catalog. You might have ACID tables, Ranger for security, do as is false, and the opposite over here on the Spark side. And there's a couple options then to share across. You can read, they can read each other's data knowing that when they cross over that it's, they need to play by a different set of rules, or you can use Hive's external tables as a kind of, I think somebody internally called it a DMZ, as a place that users could share this stuff. All right, so how am I doing? Ooh, I'm doing well on time. All right. So, as I think I've tried to be clear along the way, there's a lot of work still to do to make this happen, right? We have released the Metastore as a separate project, or a separate module, sorry, but we need to work on, does it become a sub-project or a separate top-level project? There's still a lot of work to do to integrate the schema registry into the Metastore. I'd like to start getting people who are not, who are in some of these other projects, Spark, Presto, Impala, others, involved in the Metastore and adding things that they're interested in. There's a lot of work still to do on catalog. So if you're interested in contributing to this, if you have requirements you'd like to see, if there's things in the metadata you'd like to see that you haven't yet, this is a great chance to get involved with it. With that, I'd like to thank the Hive team for the work they've done in pulling this out, and all the other projects that use us and work with us. And then I will take any questions. Yes?
How to include business metadata into this repository? Because like you always have like technical metadata and business metadata. Let's say
Okay.
F name, but what F name is like.
Sure. So how to include business metadata in that. So that's a good point. One thing that I should have said at the beginning is what is in Hive's Metastore. It is what I call runtime metadata, by which I mean it's what you need to plan and execute your jobs, right? So it's the table name, where's the data stored, what format is it in, what's the schema, those kind of questions. What if you have business metadata, like is this a PII, is this column personally identifiable information, do I need to mask it? What is the meaning of the term user, and does this column say something about the user? So I don't have a great slide on it, but well, actually I'll go back to one I kind of have here. So I don't know why it makes you unwind that. Basically the answer is we do that through various other related projects. Wow, I should have just started over. There we go. So here you see shared metadata, security, and governance. So I'll tell you the Hortonworks story. If you talk to other vendors, they'll change the names, but the idea is similar. So in the Hortonworks world, what I've been talking about, metadata is handled by the Hive Metastore, security is handled by Apache Ranger, and governance by Apache Atlas. And it's Atlas that would store this business data. And these three are all linked together so that when you, for example, create a new table, let's say in Hive that you say create table as select from some other table, and that table has some of that business metadata, like this column has information about the user, or this column is personally identifiable information. That gets carried through the query and marked on the new table in Hive and sent back to Atlas. So there is linkage between those, even though we're storing them separately. The real reason to store those separately is it's the focus about how you're retrieving that data. The data in the Metastore, like I said, is for planning how you're going to read the data. It needs to be, the serving time needs to be very fast, even though we haven't been great about that in the past. And the focus on what does a tool need to read the data versus for that business metadata, you really need to support queries from business users. The response time's a little different. If it takes you a couple seconds, that's okay. But you don't want your business user showing up and running a query that's going to bring your runtime system to its knees. You can also relax some of the HA and those things in this world if it's just business user queries, because if the system's out for half an hour, it's going to tick your governance guys off, but it's not going to, you're not throwing money on the floor as a result, right? Okay. What's that? Atlas is but again, that's in the Hortonworks answer. So if you ask some of the other distributions, they'll put a different name in there, but I think they've taken the same basic approach. Other questions? Yes? Mm-hmm. Okay, so I touched on HCat. Is that still being maintained? Yes, it's still part of Hive. It's in Hive 3.0. It's still tested as part of both the Apache and later down the road Hortonworks stack. It's all there. It just is still serving the same purpose it did before. Yeah, this does not in any way replace HCat. Like I said, it's different. Other questions? All right, cool. Despite a late start, I got you out early for lunch. So go enjoy being the first in line, and thank you for coming.